Okay, so what we got here, this is the baseline where the printer, we have this clipped around my split cord here that goes into an outlet that's plugged into the 3D printer. And this is the baseline of the controller for the printer. Got very low output. And when I go into the actual settings and say preheat, that's what we get. Now this is running through a transimpedance amplifier. We have 2,000 turns on the coil, so I have a 2K resistor running from the negative to the output, and then we're testing that on my scope and cheap multimeter, and it's coming out right out to what I thought it would. Actually, and there it shuts off from the heater because it reached temperature and it's bumping up right to the spots where it's gonna keep it hot. This is the hotbed and the extruder. You can actually see the controller switching on and off. Now I'm gonna throw this onto a nice little breadboard and make a maybe clippable, maybe screwable probe with it. Here's how we're gonna go. There will be a switch here, but we have a 12 volt in that has about a half an amp at the power supply. Goes through an LM7810 because we want about 10 volts in our positive swing to get about, you know, the full range of what we're looking for here at the 10 amps. We have a decoupling capacitor at the output of the LM7810. Then we run down and we supply an opamp, which is an LM358. It has a little tiny bit of an offset, but we're not looking for like really precise here. We just want something to see like what the pattern of the amperage is. And the positive is going to the ground, and the negative is coming up here, and it has a parallel 100 nanofarad capacitor with a 2K resistor that goes to the output, and that goes to plus out for the oscilloscope, and then the negative out will go straight into the ground of all this. Now here's our schematic of where A coming into the negative side for that 2K and 100 nanofarad capacitor that ain't gonna go there, plus A comes here, and we're creating a transimpedance amplifier. Transimpedance amplifier turns amperage into voltage, and you would take the amperage and multiply it by this resistor to get what voltage you'd get by that amperage. With 2,000 turns on the actual sensor, we're just kind of counteracting that and trying to get 1 volt per amp. Now over here I have, there's the A that's going into that, and then the other one just goes to ground. That's it. Fairly simple. There will be a switch added here, but nothing else really amazing. We're back now. Here's the apparatus that has brought forth. I have a nice little switch. This runs off into our sensor because it happen to have a 3.5 audio jack. And here goes off onto our BNC, right into the oscilloscope. As we turn her on, okay, the printer's already plugged in. So this bad boy's on. We're getting about 1.5 to 1.7 amps when she's in the heat up mode. So let's get it ready. I'll put our hand on the button. Alright, go. Bam. And it looks nice, 1.5. That's right with where my clamps and the meter got. See, the transimpedance amplifier that's taken into consideration the amount of turns on the data sheet, trying to turn it exactly into the amount of volts as the amount of amps. And you can actually watch this for a little bit, and it will go into the cool down and heat up cycles. You can watch them. It's actually kind of cool. If we look in here, I added the LED so I knew when it was on, and there's a switch that wasn't on the schematic. But other than that, it's just AC adapter in, a headphone jack that I soldered on, the two capacitors in the actual schematic, a 10 volt regulator, because I figured 10 volts gets up to 10 amps. And she looks solid, really. Yeah. Nice. Oh. Yep, 60 hertz. That would be the frequency that amperage is chugging along in, right into the heating plate. It's amazing that it comes right into it in the heating and cooling cycle. There we go, there's the cooling cycle. And thermal cool off. There's the heat again. See, it actually turned out really great. What I wanted. I just wanted a simple probe to be able to clip on to the input. With this here, it's just an extension cord I sliced up and turned into an outlet where I can plug stuff in and clip on, and then I can actually compare with stuff inside of here. The phase angle will be shifted, but it'll give me the idea. So, kind of nice. Maybe in the future I'll take and compare and figure out a way to find the phase angle shift and fix that so that I can line it up and find and see, like, say, power factor and things like that. But for right now, I just wanted something I could clip on and would show me when amperage is going. And this is perfect. It is awesome. The problem I ran into is I wanted to make this, and looking around online, there was not a lot of help. They had a bunch of stuff about using a burden resistor and stuff, and it wasn't very accurate that way. So what I decided to do was use a impedance amplifier and match the turns with the resistance. That way I get a 1-to-1. And it is just, wow, clean. It comes out really clean. I do also have a RF BNC cable, which I got for a couple projects. And that cable does make a difference and stuff. Good cable. It feels the same as my actual oscilloscope probes. You don't want a bunch of extra inductance and capacitance. Alright. Have a good one.